Hello everyone, welcome back to the channel. I hope you guys are doing really well. So we will see today's daily challenge on Leetcode and we will try to solve it together. So let's try to understand the problem statement. Count unguarded cells in the grid. So I guess the problem statement is very simple. You are given an m cross n grid, okay, and now the grid itself you are not given, but you are just told that it has dimensions m and n, whose dimensions you are given as integers m and n, okay, and you are given a vector of pairs guards which will tell you that which are the coordinates where the guards are present and which are the coordinates where the walls are present in the particular grid. Okay, so yeah, so basically you will be given something like this. You will only be given the coordinates of the guards. So you see 0 comma 0, it means that 0th row and 0th column there is a guard, and 1 comma 1 and again 2 comma 3, it means that in the index number of 2, row number 2 and index number 3 of column, you have a guard present. So yeah, it just gives you the coordinates of the guard and the coordinates of the wall, and it is told that the guard can see the cells. Okay, so in all of these four directions, vertically as well as horizontally, you get four directions, right? So in all of those four directions you can uh, look. Okay, you can look and the guard can guard those cells, and in the process what can happen is that this can be stopped by a wall. Okay, so the influence of one guard can be stopped by a wall, and it can also be stopped by some other guard. Okay, so yeah, that can happen, and you want to tell that which are those cells which are not guarded. Okay, so here are the green ones which are not guarded, and you see in this case where m is 4 and n is 6 and these are the coordinates of guards and walls, you get 7 cells which are not guarded. Okay, so you see, you count the number of green cells, and those are only my answer. Okay, so you see what you need to do is m into n is given to be 1e5, and the guards dot length and walls dot length are both 5e4, but the sum is less than or equals to 1e5, which is m into n. Okay, so I hope the problem statement is at least very clear, and it will not be very difficult if you even run the whole simulation. So what do I mean by the simulation? See, there are m cross n number of cells, right? So what I want to say that what will happen if you just in a brute force manner, you can just see whichever cells are there by a guard. Okay, let's say this cell are there by a guard. Okay, and you just want to check all of these cells. So you traverse through all the guarded cells where guard is present. Okay, so and just every time you cover in all the places, you just cover that how many cells are covered by this guard. Okay, so basically let's say you can keep a grid and assign it to all zeros. Okay, so you can keep a coding, right? So 0 means unguarded. Okay, initially you can keep all your cells as unguarded. Okay, and let's say 1 you can keep as guarded. Okay, 1 you can keep as guarded. 2 you can keep that the guard exists at that point. Okay, guard exists, you can tell that guard exists, and from this point the guard it will go on. Okay, and wall exists. Okay, so I hope you do understand. Guarded is nothing but the red cells which are there in the problem. So yeah, you can initialize an m cross n matrix by all zeros, and you can simply place a 1 whenever you see there is a 0. You can convert all those to ones. Okay, and whenever you see there is a wall, you can just break the loop. Okay, there would be no problem about that. You can just break the loop, and yeah, that's all. And if you think that time complexity might exceed by this, so it will not be. Why? Because you see there are m cross n cells, right? So you consider one cell, how many times maximum will you check it? So it is possible that you will be this cell will be overlapped by some of the guards influence. So maximum from 4 directions. Let's say if there is a guard here, there is a guard here, there is a guard here, there is a guard here. So if you are iterating, maximum each cell will be counted by 4 guards. So 4 into m into n will be your time complexity. Okay, which is nothing but of the order of O of m into n. and which is nothing but 1e5, and 1e5 easily works, right? 1e5 does easily work. And yeah, so you can run a simple brute force simulation. Okay, so as I told you, just a brute force simulation will work just fine. Okay, do not need to overthink anything on this problem. Yeah, that's all. You can, I hope you can try to do it on your own. I will also show the coding. Okay, so I will go and follow this particular analogy. Okay, so as I told you, 0 means guarded, and yeah, that's all I will do. Okay, let's see. I will just write this once again. What does 0 mean? It means unguarded. Okay, which I will initialize at first, and 1 means it is guarded. Okay, so yeah, we have it guarded. And what does 2 mean? It means nothing but guard exists. So G means 2. Okay, red cells, so these are nothing but green cells is denoted by 0. 1 red cells are denoted by 1, and 2 means G. Okay, and guard exists. Okay, right, guard exists. And this 3 means W, so it's actually wall. So I hope that is very clear. And you see, we are not given the grid, we are just given its dimension. So you can easily create a 2D array grid at first. Okay, and that will be quite simple to do. So you have a grid with m rows and n columns. Okay, so let's see about this. You first of all initialize all of these m and n with 0. Okay, so you are having all unguarded right now. So what you can do right now is go through these guards and walls and just mark all of them, whether the value is 2 or 3. So this 2 or 3 you can easily mark, right? So what I will do is very simple. I will go through nothing but guards dot size. Okay, and what I can do is that grid GURDS guards of I0 and guards of I1. I can mark it to be 2. Okay, because guard exists, as I told you, it's 2. So yeah, I can have this same very similar loop, right? Instead of guard, what I will do, I will write wall. So yeah, I will just remove this guard and I will write wall, and instead of 2 I will write a 3. I hope that's very clear. Okay, so 2 and 3 is marked, and I need to mark the ones which are which will be converted from 0 to 1. Okay, so from green to red I need to just convert those cells. Okay, so for that what I can do, I can iterate through all the guards and simply cover it up. Okay, so I will just go through all the guards. So I will have guards dot size, and after that what I can do is go in these 4 directions. Okay, so let's say I will go horizontally right at first, and then let's say write the code for that and go horizontally left, and in the vertical direction also I will try to go. So go vertically right, vertically down, right? And these are 4 directions which I will try to iterate. Okay, so yeah, at first before the iteration I will just write the rows and columns. So row is nothing but in which row and which column, which are the coordinates where guard of I is present. So I can simply mark it by this. Okay, so yeah, I just have it guards of I1 is nothing but column. Okay, and now comes the iteration part. I hope you can easily visualize that when we are going horizontally right, okay, whenever we are going horizontally right, our row is fixed but the column is changing, right? So this much I hope you can easily visualize. So if you are in this particular cell and you want to go to the right, you are in still a fixed row, but your column iterates. Your column iterates. This row is fixed, but your column iterates, right? So you can just have that. So what do I want to do? Basically is that I will write an iterator j. Since my column is iterating rightwards, I will start from c plus 1 and end till n and j less than n, and I will go for j plus plus. Okay, and I hope similar thing I can do here also, but I will start with c minus 1 as I want to go horizontally left, and the edge case will be greater than equal to 0 and it will be minus minus. Okay, and similar thing for this also, as I want to go vertically down, I want to use this row, and instead of this it will be m, and for vertically up I hope things will be very simple. It will be row minus 1 and greater than equals to 0, and it will be j minus minus. So yeah, that will happen. And I decided to iterate, and now I need to see that when I need to change this 0 to 1. So yeah, whenever I find a 0, I will directly change it to 1. So if I find grid of now what will be the grid? The column will be iterating and row will be fixed, right? So yeah, column j which will be iterating and row will be fixed. And if I find this to be 0, what will I do? I can just simply convert this to 1, right? Else if see, the influence of guard can be stopped by another guard or by having a wall. Okay, so cell is unless they're obstructed by a wall or another guard. So I will simply follow what is told in the question. So yeah, their influence, if it is either 2, what does 2 means? 2 means a guard exists or a wall exists. So if a guard or wall exists, what will I do? I can just simply break out from the loop, and it will be as simple as that. I can just copy this for all the 4 cases. All I need to do here is just change the dimensions accordingly. Okay, that I need to take care. So for this, you see, it will be the exact same thing. For this, j will come first because we are now iterating the row while we are moving in the vertical direction, and the column is fixed. Okay, so yeah, I hope that you can do that easily. So yeah, all at once I will try to change. This will be j and this will be column, and I will just try to copy the same thing over here. Okay, so yeah, that's all. You see, you are just going through all the cells whenever you find a guard. So yeah, you are iterating through all the guards and you are just going through all the cells, changing whichever is required, whichever is guarded, you are just changing it to 1. And if you encounter some other guard or a W, that is a wall, you can just simply break out from the loop. That much you can do easily. And what else is remaining? Nothing else, right? You just need to count your final answer. So you can just iterate through the grid. Okay, so you simply iterate through the grid and just count how many zeros are there. As simple as that. So you have this iterator n, and whenever you see if grid of ij is 0, I will do an answer plus plus, and that will be all. You can just simply return your answer. That will work just fine. If you try to submit it and check, I don't think there will be any errors, but let's try to see. Okay, we are getting a wrong answer, so we will try to see which portion we did a mistake. So you see the grid we initialized, we marked all the guards and the walls with 2 and 3, and we are iterating through the guards. Okay, and for every row and column. So this column, since we are going horizontally right, we will start with c plus 1 and go till n j plus plus. c minus 1 go till 0 here, and here row will be fixed, column will be iterating through j, and this thing j will be fixed, and column will be fixed, and j will be iterating, the row should be iterating. Okay, and if we are going vertically down, it will be less than m only, and vertically up will be greater than equals to 0. And whenever we find something that the grid is equals to 0, grid ij, you can just increment your answer. Okay, so why there is a mistake here? Okay, so you see, we did an AND operation here, so that is quite obvious that we should not do it. Either a guard or a wall can stop it, right? So obviously there will be an OR operation. It's quite simple. There should not be any confusion in this, at least. So yeah, you can simply submit it now directly. I hope it will work. So you see here, it does work, and we got decent runtime complexity also. There is no problem with this. And yeah, I hope our both runtime and memory is good on the next submission. You see, yeah, it varies a lot, but I hope you understood the solution. It was a simple brute force simulation which I did, no graph and nothing. We just implemented it very simply. Okay, so I hope it is the approach is at least very clear to you. Yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.